Hello. Today we're going to be solving radical equations and inequalities. So the goal is by the end of the day you're able to solve something that has x's and looks like this, or even something that like a cube root or fourth root, those types of equations and inequalities. So we're going to have like this four-step approach to solving the radical equations, and even the inequalities are going to be very similar. You're going to go ahead and get the radical alone. So it should be like the cube root of something equals a number or an expression. If there's more than one radical in the problem, you're going to get one of those radicals alone. Step 2 is going to be to raise both sides of the equation to a power that undoes the radical. In essence, you are doing the inverse operation for that nth root. So if it's a cube root, what you would do is cube both sides. Step 3 is going to be to solve the resulting equations and you might think you'd be done there, but there is a step 4. For radicals, you always have to check your answer or your answers if you have more than one. Because sometimes you get a solution that you think should work, but it does not actually work. That is called an extraneous solution. So you might get two solutions, and of those two solutions, both might work. Both might not work. One might work, the other one might not. So it all depends on the way the equation is set up. So let's go ahead and take a look at a couple of examples here. So example 1 here, the first step is to get to the radical alone. So we're going to go ahead and subtract 6. We're going to divide by 2. Once the radical is alone, then we're going to do step 2. So this is a square root. The inverse operation is to square both sides. On the left-hand side, we're left with x plus 3. On the right-hand side, we're left with 256. Step 3 is to solve the resulting equation. So you get x equals 253. But before you circle that answer, you have to do step 4 and check your answer. So always go back to the original untainted problem. So we're going to do 6 plus 2 times the square root of 256 when you add those together. 6 plus 2 times 16, that is supposed to equal 38. And 6 plus 32 does equal 38, which means x equals 253 is a solution. It is not extraneous. Now, as you can imagine, different things will pop up depending on the problems that you are working on. So for instance, 2, we're going to go ahead and subtract 3 from both sides. Then we're going to go ahead and square both sides. On the left-hand side, we get x minus 1. On the right-hand side, we get x squared minus 6x plus 9. So now our resulting equation is something that needs to be factored. So we're going to go ahead and get it equal to 0. We're subtracting subtracting x and adding 1. We're going to factor this to x minus 5 and x minus 2. So our two solutions, when we set those equal to 0, would be x equals 5 and x equals 2. So again, we might be thinking we're done here, but we really do need to check. So we have to check both of them in the original equation. So I'm going to start off with x equals 5. We get 3 plus the square root of 5 minus 1 is 4, equals x, which in this case we're trying 5. So 3 plus 2 equals 5. That one works. So let's check x equals 2. So 3 plus the square root of 2 minus 1 is 1. That's supposed to equal 2. So we get 3 plus 1 is 4, not 2. So x equals 2 is the extraneous solution. It's the extra solution that you get that you think should work, but when you plug it in, it actually does not work. So our only solution for this one is x equals 5. Let's take a look at another weird case that pops up. Here we have two square roots. So we get a radical alone, and we have one radical alone already. So as long as one of your radicals is alone, you're good. We're going to square both sides, remembering to write parentheses here. So on the left-hand side, it's x minus 12. On the right-hand side, that becomes 4 minus 4 root x plus the square root of x times the square root of x is just x. If you want to show that work of writing it twice and distributing, you can, and you will end up getting this. But now our resulting equation, once again, has a radical in it. So we're back to step 1. We now need to get the radical alone. So we're going to move the 4 and the x to the other side. As we do so, the x's luckily cancel out. Then we're going to go ahead and divide by negative 4, and we get 4 equals the square root of x. Now when we square both sides, we'll no longer have any square roots. We get x equals 16. Now there's no other resulting equation with this one. That is just our answer, but we do need to check it one more time. So the square root of 16 minus 12 is the square root of 4. And we get 2 minus the square root of 16. So 2 equals 2 minus 4. And that is not the case. 2 minus 4 would be a negative 2. So this is not actually a solution. So all of that work gives us no solution in the long run. That's not going to happen every time, so each situation is different. You're just going to have to check every single one. So that was part 1 of our notes. Thank you very much for listening.